Okay, in this video, I'm going to explain a few proofs from your homework for chapter 6. So the first one that was requested was number 10. So I'm going to go ahead and zoom in here. So I'm going to go ahead and set up my statement column and my reason column. So I'm going to state my given that Vy is perpendicular to Yz, and that's given. So over here in my picture, here are my perpendicular lines. Here's my Yv and my Yz. So this tells me that I've got a right angle here. And that's the next thing that I'm going to state. Because notice what I'm trying to get to is to show that I have an obtuse angle. So because this is a chapter on inequalities, I'm going to establish that that's going to be greater than this 90 degrees. So I'm going to go ahead and describe which angle is 90 degrees. And I'm going to call that x, y, z equals 90 degrees. I could also call this ZYX, but I'll just go ahead and use XYZ, and that's definition of perpendicular lines. Next, remember, what we need to get into our proof is that this angle here, VXZ, is obtuse. Now, notice this angle is the exterior angle of this triangle. So I'm also going to be bringing in that exterior triangle inequality theorem. So first thing I'm going to establish, or the next thing, is that if I were to add something to XYZ, this other non-adjacent remote interior angle, if I add that to XYZ, if I add angle Z, and there's only one angle there, so I can just call it angle Z, I know that this is going to be greater than 90 degrees because I've already established that XYZ equals 90, and as soon as I add another angle to it, I know it's going to be bigger or greater than 90 degrees. And my reason here is just a property of inequality. Next, I'm going to show that triangle inequality theorem, and I'm going to show that angle, this exterior angle, is going to be greater, so VXZ is greater than 90 degrees, because I know that these two green angles here equal this. So if I know that that is how it's made up, so my reason here is going to be the exterior angle of a triangle inequality theorem. And now because VXZ is greater than 90, I can state what I'm trying to prove, that angle VXZ is obtuse. And this is definition of obtuse. Let's take a look at number 12. Let's look at number 12. And I'm going to make my statement column and my reason column. Let me go ahead and do this over here. Statement, reason, state the given, that QR and ST bisect each other. Let me go ahead and label my picture. Okay, so QR and ST bisect each other. I'm trying to prove that angle XRT, this one here, do it in highlight, XRT, this angle, is greater than angle S, which is way over here. So what I'm going to do is I'm going to show that these two triangles, this one right here, this blue one, and this yellow one, are congruent triangles, and then I'm going to show the relationship between angle S and T because of the CPCT, and then I can use my property of inequality. So let me go ahead and walk through this. So far, in order to prove my two triangles, the blue and the yellow, are congruent, I've got two sides marked. I need to find a third piece, and I'm going to bring in my vertical angles. So I could state that this angle is congruent to this, and the reason is vertical angles. So that'll be my next statement. Now, I could have also stated what I labeled in my picture, that my sides, they were bisected. So either one. So if you wanted to use the given, let's do that first. Let's state what a bisector does. And let me state that SV is congruent to, let's see, VT, and QV is congruent to RV. And this is definition of a bisector. And again, if you'd rather state the vertical angles next, you can, but I did that because that was listed right above it. Next, I'll state the two vertical angles that are congruent. So I'm going to state that angle QVS is congruent to angle TVR. Let me fix that order. That is not right because I need to look at the tick marks. So QVS, let me go ahead and highlight this. QVS goes from the single tick mark to the double. So then here I'm going to do the same thing, and I'm going to go from the single, which is RVT. I'm going to state that, RVT, just so I can show you that S and T once I get there, because that's what I need to establish in my proof here. So this is vertical angles theorem. Now I can state that the two triangles, the blue and the yellow, are congruent. So I can state that QVS triangle is congruent to RVT, and my reason here is side angle side. Next, I need to establish that angle S is congruent to angle T, and once I've proven two triangles congruent, I can use the corresponding parts of congruent triangles are congruent, CPCT. And now I'm going to bring in my exterior angle of this triangle, that inequality theorem. So remember, the angle we were trying to bring in here is this one. So I'm going to state that that exterior angle, the XRT, is going to be greater than just one of its remote interiors. So remember, the two that it's going to be equal to is this one and this one. So I could say that angle XRT is greater than just angle T. And that was that exterior angle of a triangle inequality theorem. And now, instead of saying just substitution, I'm just going to say that XRT is greater than angle S. And when it's the inequality, you're just going to say it's a property of inequality. because what I did was I was already established up here that S was congruent to T, so then I just replaced it. And your reason is a property of inequality. So that's number 12. The next one you guys wanted to, or that was requested to see in the video, was number 17. Okay, so the other question is number 17. So what we need to do is order these angles from greatest to least. So we're gonna be ordering angle 1, and let me go ahead and put what the side across from it is. So for angle 1, that's how we're gonna tell which one is the largest angle, by comparing it to its side length that it's across from. So angle 1 is up here, and you can see that it's across from 9. Angle 2 is across from 15. Angle X is across from, now we're talking about now actually this one, you can look at it two ways. You can either look at it and see that it's across from the 15, and it's also across from the 12. So what we can do, this information is going to help us to determine which one's bigger, the 2 or the X. Then the other angle we need is angle Y. Angle Y, it's either across from the 12 or the 13. So because we're going to be comparing X, Y, and Z, and it'll be easier to use the larger triangle, that's what we can do there. So angle Y will be across from 13. And then this last angle, X to Z to Y, is this angle up here. So it's across from the 5 plus 9, which is 14. So for this one, the only thing that we have to clarify is which one is bigger. Is angle 2 bigger, or is angle X bigger? So if you go back and you look at the comparison of where it ranks within the smaller triangle, notice angle X, if I were to look at just this little triangle, notice the hypotenuse would be this one, and then this 12 would be the second biggest. So this tells me that angle X is definitely going to be smaller than angle 2, because angle 2 is across from 15. So for my rankings here, it's going to be the largest angle is angle 2. Then next will come angle X. Then after that, the one with the 14, it'll be angle XZY. And then angle Y, which is 13. And then lastly, angle 1. And again, they had these greater than symbols. So this was the biggest angle, this was the smallest. And then the other one that you wanted to see was number 19. So let me go ahead and get this set up. Statement column, reason column. Go ahead and write my given. So we're given that this is a parallelogram, EFGH, and that side length EF is greater than FG. It wants me to prove also that angle 1 is greater than angle 2. So what I can do here is, it might be beneficial maybe to add some numbers to my picture so I can see, maybe that will be helpful. So if I know that EF is greater than FG, I could say maybe this one's 8, this one's 10, because remember they told me it was a parallelogram, so I know opposite sides are congruent. And then I also know that opposite angles are congruent. So because I just added in that these sides were congruent, that could be my next statement. So this was given. And then I'm going to show that EH is equal to EHFG. And then the other one, HG, is congruent to EF. And this is opposite sides, oops, this should be a 2. Opposite sides of a parallelogram are congruent. That's that theorem. Okay, number 3. My next step is I'm going to do a substitution. So if you can already see that EF is congruent to HG, then what I can do is I can substitute. And I can state that HG is greater than HE. So just let's do it this way so you can see that a little clearer. So now, this would be substitution. So then now what I can state is use the same idea that I used for the other problem to see which angle is across from the bigger side. I could say that angle 1 is greater than angle 2, and this reason would be the angle opposite the longer side is the larger angle. So if you looked at it, to create angle 1, it would be here, it's across from the 10, and then if you were to create angle 2, it goes from here to here, and it's across from the shorter side, which I had given it a number to show, give it more of a visual. It's across from the 8, so that's why I can make that last statement. And that's what we were trying to prove, that the measure of angle 1 is greater than the measure of angle 2.